We're now going to begin our Chapter 12 Solutions Notes. We're going to talk about mixtures. First thing is define a solution. A solution is a homogeneous mixture. Homogeneous mixture means that there are two or more substances mixed together, but there is only one phase. So as you copy this down, what we're saying is as we look at it, we're just going to see one phase only. Here is an example I have of salt water. All you see is the salt water. You only see one phase. You don't see anything else in there. That would be a solution. So to draw a solution, what you would draw is you would just draw one phase. Okay? But of course if we zoom in, what you'll see is you'll actually see the water phase. And then you'll see solute. Now this is because we're zooming in. Without zooming in, you'd only see one phase. But I just want to show you what's really inside a solution. It is a homogeneous mixture. Okay? So in the solution, we have something called the solvent and the solute. The solvent is what's doing the dissolving. Solute's doing the dissolving. It's also the part in the greatest amount. So when you're looking at a solution, whichever is in the greatest amount is going to be the solvent. What's getting dissolved is going to be the solute. The solute is the part that is getting dissolved. Give you a second to write those down. And so what we're going to do now is we want to label our drawing. Let's label the solvent and the solute. Well, the solvent is what's in the greatest amount. So for my circles, you can see that I have more circles than squares. So this is going to be my solvent. My solvent is going to be my water. And then my solute is going to be the salt that I put in. So this is how you would label the solution with the solute and the solvent. Okay. Next, let's try a couple of practice problems. Circle the solvent and put a square around the solute. 70% alcohol. When we say 70% alcohol, there must be 30% of something else. Whenever we say that, that means the other 30% is going to be water. So what is going to be in the greatest amount? Well, 70% is my greatest amount. So that's going to be my solvent. And the solute is going to be my water. So hydrogen peroxide, it says 30%. Well, that means the rest of it has to be water. So that means it's 70% water. So which do I have more of? What's in the greatest amount? The greatest amount is my solvent. And so my solvent is going to be my water. And the solute is going to be the hydrogen peroxide. When you make Kool-Aid in water, of course you put Kool-Aid in water. What do you have most of? Hopefully if you make the Kool-Aid right, you're going to have more water. And so the Kool-Aid is going to be the solute. Gases are also a solution. Doesn't just have to be liquids. So air is 80% nitrogen and 20% oxygen. The oxygen, of course, is what we breathe. So believe it or not, nitrogen is really a solvent that has oxygen, the solute, dissolved in it. 5 grams of copper, 100 mils of water. What do you have most of? We're going to have more water. And the copper, of course, is going to be my solute. And you can also have a gold ring. When you wear a gold ring, it's not pure gold. So it's going to be 60% gold, 40% silver. And even though it's a solid, it is a homogeneous mixture. Because when you look at it, all you see is the gold ring. And since it's 60% gold, that means it's going to be the solvent and the solute. Okay. So now we know solvents and solutes. Next thing is concentration. Concentration tells how much solute is mixed in the solution. Because when we make them, we want to know how much we put in there. So as you copy that down, I have an example here. I have this solution here, but then I also have this solution here. You can tell that one's much more concentrated. Okay, well the concentration is going to tell me how much. So I put 1 gram per cup, 5 grams per cup. And that's type of how we would say a concentration. Okay? So how much solid is mixed in the solvent? All right. So let's see if we can, let's zoom in now on concentrations. So draw 3 beakers and shade them to show concentration increasing from the first beaker to the next. So what you would show is 3 beakers. We want to show the concentration increasing. So that means this is going to be a light amount. This should be heavier. And this would be heaviest. So we're just trying to show concentration. A lot of stuff in here, so that's going to be my dark one. Not much stuff in here, so it's going to be my light one. Okay. Unfortunately, for beakers like this, you can't tell because there's no color to it. You just have to like measure it, taste it, other ways to tell its concentration. Okay. So let's show dots to show the concentrated and a dilute solution. So we're concentrated means when you have a solution, you're going to have a whole lot of solutes. That's going to be concentrated. And a dilute solution is not going to have much in it at all. That's going to be my dilute solution. So just a visual way for you to see a solution that's concentrated and dilute. Okay, so misconceptions about this concentration. What happens at concentration of a solution is some of it is poured out. So if I have this solution right here, it's a concentration of, let's act like it's 10 grams per milliliter. Okay, if I pour a little bit of it out and bring it back, what's my concentration? Well, it's the same. It's still 10 grams per milliliter. So what happens to the concentration if you pour it out? It stays the same. It's kind of like if you have a great thing of Kool-Aid, it tastes great. If you pour some out or drink some of it, when you taste more, it's still going to taste the same because pouring it out does not change the concentration. But what happens to the concentration if you add more liquid? Well, adding more liquid is kind of like your Kool-Aid. If your Kool-Aid tastes great, you put in 10 grams per milliliter, and then you add more water to it, it's going to taste yucky. It's not going to taste as good, so maybe the concentration now is like 8 grams per milliliter. It's not as concentrated. You diluted it. So what happens to the concentration as more water is added? It decreases, or you can say it is diluted. Okay. And the last thing, what happens to concentration if more solute is added to a saturated solution? We haven't learned what saturated solution is yet, but I'm going to talk about just for a second here. A saturated solution is when you're making salt water, when you add more salt and the salt starts collecting at the bottom, no more will dissolve. We have what's called a saturated solution. No more will dissolve. So what happens then if I put in more salt? Okay, is it going to dissolve? Well, no. What it's going to do is it's just going to fall to the bottom, and you're just going to have more salt at the bottom. Okay, so what I'm talking about is this: if you have a solution and you pour more and you put more salt in, and it dissolves, well, then it got more concentrated. You put more salt in, it dissolves, you get more concentrated. You put more salt in, it dissolves, you get more concentrated. Finally, you're going to add enough salt that is finally going to stay at the bottom. It will not dissolve. Any more salt you add will not dissolve in the solution, and so it's going to be as concentrated as it can. So the most concentrated solution you can have is, we call it a saturated solution, is when you fill it up with liquid, you add as much solute as you can to where no more dissolves. Then this concentration stays the same. It does not change as long as there's stuff at the bottom. So what happens to the concentration if more solute is added to a saturated solution? It stays the same. Okay. I mention that because I have kids that they see stuff at the bottom and they're trying to make different concentrations of solution. So even though there's stuff at the bottom, they'll add more, thinking that they're changing the concentration, but they're not. Anytime you see a saturated solution, the concentration stays the same. Next video I'm going to show you then is how do you determine the concentration of a solution. So we know that solutions can be concentrated, and the concentration tells how much is in there. Well, let's find out ways to determine how much solute is in this solvent.